Question number 16 says if A times 1 upon B plus 1 upon C, comma B times 1 upon C plus 1 upon A, C times 1 upon A plus 1 upon B are in AP, prove that A, B, C are in AP. Now, how will we go about proving this? So, there's one simple condition. There's one way which says if A, B, C are in AP, this implies 2B is equal to A plus C. Yes, 2B is equal to A plus C. And the converse is also true, that if this, then this implies this. Okay, so I can get rid of this. ABC in AP implies this, and the converse is also true. So this is one of the methods which is useful in simple questions for that matter. Can this question be solved using this? Yes, this question can also be solved using this. But there is another idea which is useful for proving that numbers are in AP. If you are given A, B, C in AP, that implies that you can multiply the numbers by any number, any fixed number. Let's say KA, KB, KC will be in AP. Okay, if ABC are in AP, then KA, KB, KC will also be in AP. Common difference will be KD. This also implies that A plus lambda, B plus lambda, C plus lambda will also be in AP. So the second point actually can be read as that if three numbers are in AP, you can multiply all the numbers by, or if you have an AP, you can multiply all terms of the AP by some non-zero number and still, or by some number and still the numbers will be in AP. If you are given an AP, you can add some constant to each and every term and the resulting sequence will also be in AP. Here the common difference changes, here the common difference remains same. Okay, so there are two ideas, and yes, those two ideas are used to prove such questions. Let's take a look at this question using, first of all, I will use the second idea, which is easier in this, and then I'll show you calculations using the first idea. Right. So if A times 1 upon B plus 1 upon C, A times 1 upon B plus 1 upon C, comma B times 1 upon C plus 1 upon A, comma C times 1 upon A plus 1 upon B are in AP. This is given, right? These three numbers are in AP. Where do we want to reach? We want to reach this stage. A, B, C are in AP. If you see, I have A, B and C in the numerators. Just have something extra with all of these terms, yes? This is A upon B, A upon C. Something is missing from here. What is that? A upon A. Had there been A upon A, life would have been a bit simpler, right? Because 1 upon A, 1 upon B, 1 upon C will come in the bracket, right? Here also you can see B upon C, B upon A is there. B upon B is missing. Had there been B upon B, I would have taken B common, 1 upon A, 1 upon B, 1 upon C will be present over here. Similarly, over here. So if creating A upon A, B upon B, C upon C, what are we doing? A upon A is 1, B upon B is also 1, C upon C is 1. So we can add 1 to all these terms. Add 1 to each term. The resulting sequence will still be an AP. Yes. A 1 upon B plus 1 upon C, and that 1 can actually be written as A upon A for this one, comma B times 1 upon C plus 1 upon A plus 1 can be written as B upon B, comma C 1 upon A plus 1 upon B plus 1 can be written as C upon C. These three terms will be in AP. Yes or no? Yes. Can I take out A common from all these terms? Yes. What do I have? I have 1 upon B plus 1 upon C plus 1 upon A, comma B is okay. What do I have? 1 upon C plus 1 upon A plus 1 upon B, comma C is also okay. I have 1 upon A plus 1 upon B plus 1 upon C, and these are in AP. Yes, just simple analysis over there. Simple calculation. Now do I observe 1 upon A plus 1 upon B plus 1 upon C, 1 upon A, 1 upon B, 1 upon C, 1 upon B, 1 upon A, 1 upon C. Over here, can I divide by this expression? Can I divide by these terms over there? Divide all terms by 1 upon A plus 1 upon B plus 1 upon C. You are dividing by this or you are multiplying by the reciprocal of this. One and the same thing, right? So dividing by this or multiplying by the reciprocal of this, if each term is multiplied with the reciprocal of this expression over here, then the resulting sequence will also be an AP. Multiplication by the same constant will also be an AP. This tells me A, comma, B, comma, C. You observe these will be the numbers. These will be in AP. Hence proved. Is that okay? Yes, that's the complete proof using this idea over here. What about the other idea, the first one, direct one? Will we be able to solve this question using that idea? Yes. But approach will look like this only. Why? Because you need to simplify the calculations here. So alternative method. If it is given that these numbers are in AP, I can write 2B 1 upon C plus 1 upon A is equal to first term A 1 upon B plus 1 upon C plus C times 1 upon A plus 1 upon B. Now if you observe carefully, what do I need to do? I need to remain, this 2B should remain as it is, A and C should also remain as it is, yes or no? Yes. These factors are creating problems, yes, and there are complicated things in the denominator. Simplification will be an issue. Will be an issue, yes. So how will we simplify this? We'll simplify this with simple common sense. What we'll do is, okay, let's add 1 to this term, add 1 to this term. If you're adding 2 on the right hand side, you should add 2 on the left hand side, yes. Next, 2B and 2, I want to take out 2B common. What remains is 1 upon C plus 1 upon A. Oh, there's no B over here. I give it a B in the numerator and denominator. This is what you do. Is equal to A times, I take out A common from here, 1 upon B plus 1 upon C plus 1 upon A remains. Similarly, I take out a C common, 1 upon A plus 1 upon B plus this one converts to 1 upon C, right? If take out C common. Oh, you've applied similar steps. Yes, I have applied similar steps so that calculations remain easy, right? And now I can cancel this factor. This is the same factor, so that implies 2B is equal to A plus C, which implies A, B, C will be in AP. Hence, proved. Is that a complete proof? Yes, that's a complete proof of this particular question, as you can see over here.